Welcome to For Science Salah Lotfy channel. Today, I'm diving into one of the most debated and misunderstood topics in modern nuclear science, thorium, the promising, yet complex element that could shape the future of nuclear energy. Let's explore what the science actually says based on the landmark report by the OECD Nuclear Energy Agency, Introduction of Thorium in the Nuclear Fuel Cycle. From the very beginning of the nuclear era, thorium has attracted global scientific attention. Unlike uranium, thorium is more abundant in Earth's crust, and was once considered a potential alternative to avoid projected uranium shortages. But why hasn't it replaced uranium yet? The answer lies in its nuclear nature. Thorium itself isn't fissile. It must first absorb a neutron to become uranium-233, a fissile material. This means it can't start a chain reaction on its own. Despite that, thorium's scientific appeal hasn't faded. Its potential for safer, more sustainable energy keeps it at the heart of research in India, Europe, Canada, and China. Let's look at the science. First, superior material properties. Thorium-based fuels have a higher melting point and better thermal conductivity, making them suitable for accident-tolerant fuel designs. Second, reduced nuclear waste. Thorium generates fewer transuranic elements compared to uranium, meaning lower long-term radiotoxicity and improved waste management. Third, lower plutonium production when used with uranium. Thorium reduces plutonium buildup, an advantage from both safety and proliferation perspectives. Fourth, high conversion ratios in thermal reactors. Uranium-233 offers excellent neutron economy, enabling near self-sustaining fuel cycles under the right conditions. And fifth, fuel performance enhancer. Adding thorium to uranium oxide fuel improves ceramic stability and reactor safety margins without radical changes to reactor design. But it's not all smooth sailing. Fuel reprocessing complexity is a big challenge. Recycling thorium fuels requires advanced, shielded facilities due to the presence of uranium-232, a strong gamma emitter. This makes fuel handling and reprocessing far more expensive than in the traditional uranium-plutonium cycle. There's also slow industrial adoption. Fuel qualification, licensing, and irradiation testing take decades. Full industrial deployment of thorium fuel cycles would need long-term commitment and high investment. And then proliferation misconceptions. Though thorium is often seen as non-proliferative, it can still produce weapons-usable uranium-233. However, the gamma radiation from U-232 helps deter misuse, adding a layer of self-protection. So, while thorium has gained attention in media and public discourse, it's often oversold as a miracle fuel. The truth is more nuanced. The NEA report offers a balanced, science-based assessment. Thorium is promising but not without obstacles. Its role will depend on long-term policy choices, industrial readiness, and global energy strategies. As we face the dual challenge of climate change and energy demand, thorium deserves to remain part of the conversation, not as a silver bullet, but as one of several tools in the nuclear toolbox. Thank you for watching. This is For Science Salah Lotfy channel, where science speaks clearly. Hey everyone, welcome back to For Science Salah Lotfy channel, where your curiosity drives the conversation. Today's video was sparked by some truly insightful questions from you all specifically. What is thorium's role in nuclear reactors? I'll be honest, this isn't a topic you can just skim over. Thorium reactors could change the entire energy game, so, in the spirit of real science, I'm launching a whole series on this subject. You'll find every episode in the playlist Introduction of Thorium in the Nuclear Fuel Cycle. This way we get to break down the science, the tech, and the strategy behind using thorium and nuclear energy together and in detail. Now, I don't want to just give you my take. For the best answers, I turn to our nuclear advisor, Professor Dr. Tarek Nagla, former professor at the Egyptian Nuclear Power Plants Authority. His go-to resource for all things thorium, a heavyweight report, Introduction of Thorium in the Nuclear Fuel Cycle, short to long-term considerations by the Nuclear Energy Agency under the OECD. Trust me, this isn't just bedtime reading, this is the stuff that shapes international nuclear policy. Let's get to the heart of it. Why should anyone even care about thorium? Well, the NEA report lays it out. Thorium has some serious potential. Imagine a nuclear fuel that could make reactors safer, produce less long-lived waste, and work with next-generation reactors designed for efficiency. That's what thorium brings to the table. On paper, it sounds like a no-brainer, right? But here's the kicker. There are challenges. Technical hurdles, economic questions, and the fact that our current infrastructure just isn't built for thorium yet. The report doesn't sugarcoat it. If we want a thorium-powered future, it's going to take sustained research, investment, and international cooperation. So, if you're as fascinated as I am by the idea of revolutionizing nuclear energy, or if you've got questions about the science behind the headlines, stick with this series. I want to thank Professor Dr. Tarek Nagla for always pointing us to the good stuff and helping us keep things rigorous and relevant. And of course, if you've got more burning questions or want us to dive deeper into anything nuclear, drop a comment below. Your curiosity fuels this channel. Thanks for watching, and remember, stay curious, stay informed, and subscribe to For Science Salah Lotfy channel for more evidence-based science content. Today, we're diving into the world of nuclear energy with a twist: thorium. You've probably heard of uranium, the classic nuclear fuel. But what if I told you its neighbor on the periodic table, thorium, could make nuclear power safer, cleaner, and more sustainable? The way we use nuclear energy today creates long-lasting radioactive waste and relies on rare uranium. Scientists have been eyeing thorium for decades as a way to tackle these challenges. Thorium isn't about replacing uranium overnight, but about upgrading our energy system for the future. The idea has been around since the 1950s, but now, with climate change and the need for safer energy, thorium is making a comeback. Experts are exploring how thorium can help us manage nuclear materials more responsibly and provide clean energy for generations. So, what makes thorium special? Why are top scientists excited about it? We'll break down the science, the challenges, and the possibilities. Thorium could be a game changer for our energy future. Let's find out how. Switching to thorium isn't as simple as swapping fuels. Our entire nuclear industry is built around uranium. Changing that is a massive undertaking. The technology for thorium exists, but we lack large-scale experience and need to develop the full fuel cycle, from fuel prep to recycling. Each step brings technical puzzles that require years of research and testing. Then there's the cost. Building new infrastructure is expensive, and uranium is still cheap, so there's little financial incentive for a big switch. The benefits of thorium are long-term, not immediate, making it a tough sell for investors. Regulations are another hurdle. Our safety rules are written for uranium, so new ones would be needed for thorium. Public trust is essential, so transparency about both benefits and challenges is key. This transition is a marathon, not a sprint. It's about careful planning, investment, and building confidence step by step. The payoff: a safer, smarter nuclear future. Why go through all this trouble for thorium? 3 big reasons. First, thorium reactors produce far less plutonium and other weaponizable materials, making nuclear energy safer for global security. Second, thorium waste is much less radioactive over the long term, decaying in hundreds, not hundreds of thousands of years. This makes waste management more realistic for future generations. Third, thorium is 3 to 4 times more abundant than uranium, offering a vast untapped energy resource. Using thorium means a more sustainable nuclear fuel supply for centuries. These goals, better security, less waste, and resource sustainability, are why experts are excited. It's not about cheaper energy tomorrow, but a smarter, safer system for the future. Investing in thorium is about building a better energy legacy. Science in action, solving tomorrow's problems today. That's why thorium matters. How could we actually transition to thorium? It's a step-by-step journey. In the short term, we can mix thorium with uranium or plutonium in existing reactors to gather data and train experts. No new plants needed. By the 2030s and 2040s, we could see new reactors designed specifically for thorium, like molten salt or high-temperature gas-cooled reactors with built-in safety features. The focus will be on proving these systems work reliably and economically. Long-term, after 2050, the dream is a closed thorium fuel cycle, recycling used fuel for maximum efficiency and minimal waste. This would make nuclear power incredibly sustainable. Each phase builds on the last, allowing us to learn and adapt safely. It's a bold vision, but with practical steps. The journey starts now. Recycling thorium fuel is both a huge opportunity and a major challenge. When thorium is used in a reactor, it turns into uranium-233, which powers the reaction. After use, we can separate out uranium-233 and reuse it, an efficient closed cycle. But there's a catch. A byproduct, uranium-232, emits intense gamma radiation, making recycling complex and expensive. Everything must be handled remotely, behind heavy shielding. This radiation is a double-edged sword. It complicates recycling but also makes the fuel much harder to steal for weapons. That's called proliferation resistance, a big safety plus. Cracking the code of thorium recycling means developing new robotic processes and materials that can withstand radiation. Scientists are exploring advanced techniques like pyrometallurgical processing. Solving this challenge is key to unlocking thorium's full potential. What do the experts say? The U.S. Department of Energy did a deep dive into future nuclear options, including thorium. Their verdict: thorium is potentially promising, great on paper but not ready for prime time. They recognize the benefits: less waste, better resource use, and strong security features. But they also flagged big technical and cost hurdles, especially in fuel fabrication and recycling. The DOE recommends continued research, not a massive switch right now. Thorium is a valuable backup plan and a long-term goal, not an immediate replacement. If uranium prices spike or security needs change, we'll be ready. For now, thorium stays on the research agenda. What can we do with thorium right now? Use it as a helper fuel in existing reactors. By mixing thorium with plutonium or enriched uranium, we can create thorium matrix fuel rods. This lets us start using thorium without building new plants. The main benefit is learning real-world data on how thorium performs under reactor conditions. It also helps us safely burn up existing plutonium stockpiles, turning a waste problem into clean energy. This approach is low risk and leverages our current infrastructure. It's a smart, pragmatic first step. We reduce long-lived waste and build the knowledge base for future thorium reactors. It's the perfect way to begin the thorium journey. Small steps now, big benefits later. Looking to 2030-2050, thorium could power advanced reactors designed for maximum safety and efficiency. Molten salt reactors, for example, use liquid fuel and can shut down safely using simple physics. These designs allow continuous refueling and waste removal, making them more efficient and producing less waste. Thorium's properties fit perfectly with these next-gen reactors. The result? Less long-lived waste and easier management. This could help nuclear energy gain wider public acceptance as a climate solution, but it will require major investment, research, and international collaboration. If successful, this could usher in a new golden age for nuclear power. Thorium and advanced reactors, a powerful combination for the future. Let's be honest, thorium isn't a magic fix for all our energy problems. It won't make nuclear power dramatically cheaper. Most costs come from building the plants, not the fuel. Thorium cycles can cut long-lived waste, but they don't eliminate nuclear waste entirely. We'll still need robust waste management for short-term radioactive byproducts and specialized recycling waste. Some plans rely on fast reactors, but progress has been slow. Thorium offers a valuable alternative. It gives us more options and resilience in our energy strategy. Thorium isn't about replacing uranium, but complementing it for a smarter, safer system. The best path is continued research, honest assessment, and realistic expectations. Thorium is a powerful tool in our nuclear toolbox. Not the only one, but a great one. It's a thoughtful, science-based approach to a cleaner energy future. Thanks for exploring thorium with me. Hello science fans, Bill Nye here. Today we're diving into the world of nuclear energy with a twist: thorium. For decades, uranium has powered our nuclear plants, but what if there's a better option? Thorium, named after the Norse god of thunder, could be safer, cleaner, and more abundant. So why aren't we using it? The shift from uranium to thorium is a massive challenge, requiring new tech, safety protocols, and lots of research. The big idea: change our nuclear fuel cycle from uranium to thorium. Thorium is more common, can produce less long-lived waste, and some designs could be inherently safer. These are huge benefits for a carbon-free future. Over the next few scenes, we'll explore the science, the promise, and the hurdles of thorium. Is it the superhero of our energy future or just a promising contender? Let's find out together. The world of atoms is waiting. Why consider switching to thorium? It's not just about novelty. It's about solving nuclear power's biggest challenges. Uranium is cheap and familiar, but thorium offers long-term advantages. Thorium cycles produce uranium-233, which is harder to weaponize due to radioactive contamination, making it more secure. Waste management is another driver. Thorium produces less long-lived radioactive waste, simplifying disposal. Its waste decays to safe levels in hundreds, not hundreds of thousands of years. Thorium is also 3 to 4 times more abundant than uranium, found worldwide, boosting energy security. The economic case isn't urgent, but the strategic benefits are clear. It's about building a safer, more sustainable nuclear system for the future. Less waste, more security, and a resource that could last for millennia. That's a vision worth exploring. The push for thorium is about the long game. Let's see how it could reshape nuclear energy. Transitioning to thorium isn't a flip of a switch, it's a phased journey. Short term, before 2030, add small amounts of thorium to existing uranium fuel in today's reactors. It's a low-risk way to gain experience. Medium term, 2030-2050, ramp up thorium use, design new fuel assemblies and retrofit reactors. The goal: cut carbon emissions and reduce long-lived waste. Long-term, post-2050, deploy advanced reactors built for thorium, like molten salt reactors which can breed more fuel, burn waste, and operate ultra-safely. Each phase builds confidence and knowledge, making the transition manageable. Short-term, get our feet wet. Medium-term, start swimming. Long-term, explore a new ocean of energy. This step-by-step approach helps us tackle technical and economic challenges. It's a marathon, not a sprint. With a clear roadmap, we can move toward a cleaner, more secure energy future. Let's break down the journey. Here's a big challenge. Recycling thorium fuel. Thorium absorbs a neutron and becomes uranium-233, the real energy producer. But recycling U-233 is tough because it's contaminated with U-232, which decays into isotopes that emit intense gamma rays. Handling this fuel safely requires remote, heavily shielded facilities, expensive and complex. The U-232 problem makes thorium fuel more secure against theft, but also harder and costlier to recycle. This is a major industrial barrier. Solving it means developing advanced robotics and materials for safe handling. That's why thorium hasn't taken over yet. The recycling riddle is as much about engineering as chemistry. Before thorium can shine, we need to crack this challenge. It's a key puzzle for the future. In 2014, the U.S. Department of Energy took a hard look at nuclear fuel cycles, including thorium. Their conclusion? Stick with uranium-plutonium for now. It's practical, familiar, and supported by existing infrastructure. There's no urgent crisis forcing a switch. But the DOE didn't dismiss thorium. They highlighted its long-term promise. Abundant, less waste, and more secure. Thorium isn't ready for prime time, but it deserves continued research. The report recommended against a massive immediate push, but urged ongoing R&D. Keep uranium as the workhorse, but keep thorium in the wings. Solve the technical puzzles, especially recycling. When the time is right, thorium could step up. The message: be ready for the future. Research now, deploy when the world is ready. What's the first step before 2030? Start small. Add thorium to existing uranium fuel in today's reactors. This thorium-add fuel can be used without major plant changes. It lets us gather real-world data on thorium's behavior and performance. Even small amounts can stabilize power output and slightly extend fuel life. It also reduces plutonium production, helping with waste and security. This isn't a game changer yet, but it's a crucial learning phase. It won't solve all challenges, but it builds experience and confidence. Think of it as a bridge to bigger changes. The industry can prepare for more ambitious thorium use down the road. It's the first chapter in thorium's story. After 2030, the world's push for clean energy intensifies. Thorium's role grows. Use it in larger quantities to maximize safety and waste reduction. Countries like France could use thorium to help burn plutonium stockpiles, turning waste into energy. This approach reduces proliferation risks and legacy waste. More thorium means less long-lived radioactive waste per unit of electricity. That makes nuclear energy more acceptable to the public. Improving safety and waste is key to building new plants and meeting climate goals. The medium term is when thorium's promises must become reality. Modified reactors will use thorium-based fuels more effectively. It's a vital step toward a cleaner, safer nuclear future. Thorium bridges today's tech and tomorrow's revolution. Thorium is abundant, but that doesn't make it cheaper. The cost of raw fuel is a tiny part of nuclear power's total price. Most costs come from building and running the plant, not the fuel itself. Switching to thorium won't save much money. Developing new infrastructure is expensive. Preparing thorium fuel is currently pricier than uranium, needing special driver fuels and handling. The real value of thorium isn't in short-term savings, but in long-term benefits. Less waste, more sustainability and safety. The economic case will only improve if uranium prices soar or thorium tech gets much cheaper. For now, uranium remains the practical choice. Thorium's appeal is strategic, not economic, at least for now. The future could tip the balance. Fast reactors are the future dream. Super efficient but tough and costly to build. Delays and technical hurdles have slowed their rollout. Thorium offers an alternative. It can be used in thermal reactors we already know, like molten salt designs to achieve high fuel efficiency. A thorium thermal breeder could stretch our fuel resources for centuries without the headaches of fast reactors. If fast reactors are delayed, thorium is a solid plan B. Developing thorium tech in parallel gives us more options. If fast reactors succeed, thorium can work in them too. It's about hedging our bets and diversifying our energy future. Multiple pathways make nuclear energy more resilient. Thorium keeps our options open. That's smart planning for a changing world. So, what's the verdict on thorium? It's not a magic bullet, and switching from uranium is a huge challenge. The DOE says uranium is practical for now, but thorium's potential is too big to ignore. Thorium could cut long-lived waste, resist proliferation, and is super abundant. These are answers to nuclear's biggest concerns. The path forward: keep researching, start small, and solve the tough problems like recycling. It's not about abandoning uranium, but adding another tool to our energy kit. Thorium could make nuclear power safer, cleaner, and more sustainable. The challenges are real, but so is the prize. Continued research is a wise investment in our future. Exploring thorium today could power a brighter tomorrow. That's what science is all about. Hello, science fans. Today we're diving into a lesser-known nuclear fuel, thorium. Most nuclear plants use uranium, but thorium is 3 to 4 times more common in Earth's crust. Thorium can't start a chain reaction on its own. It needs to absorb a neutron and become uranium-233, which is fissile. This extra step brings big benefits: safer reactors, less long-lived waste, and lower risk of weaponization. Thorium reactors were first tested in the 1960s at Oak Ridge National Laboratory, but uranium won out due to Cold War priorities. Now, with climate change and a focus on safety, thorium is back in the spotlight. Countries like India, China, and the US are revisiting thorium as a clean energy source. The big question: could thorium help power our future? To answer that, we need to explore the science, challenges, and possibilities of the thorium fuel cycle. Thorium's abundance and unique properties could change the way we think about nuclear energy. It's not just about more fuel. It's about a fundamentally different approach to nuclear power. Imagine reactors that are safer by design and produce less dangerous waste. Thorium could be a game changer for clean energy, but making it work at scale is a complex challenge. The world is watching to see if thorium can deliver on its promise. Let's dig deeper into why thorium matters. Could this overlooked element be the key to a sustainable energy future? Let's find out. Why consider thorium? It's about diversifying our energy options. Relying solely on uranium limits us. Thorium opens new doors. Thorium reactors, especially molten salt designs, offer passive safety. If they overheat, the reaction slows or stops automatically. This could make nuclear power safer and more reliable. But switching to thorium isn't easy. The entire industry is built around uranium, from supply chains to regulations. Adopting thorium means investing in new research, reactor designs, and fuel facilities. A massive undertaking. There's also a technical challenge. Thorium fuel produces uranium-232, which emits intense gamma radiation, making handling and recycling difficult. We'd need advanced robotics and shielding to manage it safely. These hurdles mean thorium isn't a quick fix, but a long-term investment. Still, the potential for safer, more sustainable nuclear power makes it worth exploring. Thorium could help solve some of nuclear energy's biggest challenges. It's about building a more resilient and flexible energy future. The road is long, but the rewards could be transformative. Let's see what thorium can really offer. Thorium's main advantages: better fuel management, less waste, and saving uranium. Thorium reactors can burn up existing plutonium, turning a waste problem into an energy resource. They also produce less long-lived radioactive waste. Thorium waste becomes safe in a few hundred years, not millennia. This could simplify nuclear waste storage for future generations. Thorium is far more abundant than uranium, extending our fuel supply for thousands of years. Using thorium means more sustainable nuclear power. It's about efficiency, safety, and responsible resource use. Achieving this vision requires major scientific and engineering advances, but the payoff: cleaner, safer, and longer-lasting energy. Thorium isn't just a new fuel, it's a new way to think about nuclear power. The potential is huge if we can overcome the technical challenges. That's why researchers are so excited about thorium's promise. How do we transition to thorium? It's a step-by-step process. Short term, use thorium mixed with uranium or plutonium in existing reactors. No need for brand new designs yet. This lets us gain real-world experience and data with minimal risk. Medium term, design new reactors optimized for thorium, like advanced light water or gas-cooled reactors. These would be built from the ground up to maximize thorium's benefits. Long-term, deploy advanced systems like molten salt or fast-spectrum reactors that can run on a closed thorium fuel cycle. These reactors could breed their own fuel, creating a sustainable energy source for centuries. Each phase builds on the last, moving from small-scale trials to full-scale sustainable thorium power. It's a long journey, but each step brings us closer to a cleaner energy future. The roadmap is clear. Start small, learn, and scale up. Thorium's promise depends on steady progress and innovation. The destination? A truly sustainable nuclear future. The biggest technical hurdle for thorium? Recycling the used fuel. Thorium fuel produces uranium-232, which decays into isotopes that emit powerful gamma rays. This makes handling and recycling thorium fuel extremely challenging. Everything must be done remotely with heavy shielding. Building and maintaining such facilities is expensive and complex. On the plus side, this intense radiation makes the fuel hard to steal for weapons. Scientists are developing new chemical processes, like pyrometallurgical methods, to handle these materials more safely. But these technologies are still experimental. Solving the recycling challenge is key to unlocking thorium's full potential. It's a tough problem, but progress is being made. With innovation, thorium could become a practical, sustainable energy source. What do the experts think? Studies by the U.S. Department of Energy and others confirm thorium's potential for safer waste, better resource use, and non-proliferation. But they also highlight the massive investment and research needed to make thorium practical. Thorium technology is far less mature than uranium. There's limited real-world data. Experts agree. Thorium isn't a short-term fix, but a long-term option worth developing in parallel with uranium. Continued research is essential on fuel fabrication, reprocessing, reactor design, and materials. If uranium prices spike or we need to burn plutonium stockpiles, having thorium ready could be invaluable. The consensus: keep exploring thorium, fund demonstration projects, and build expertise. Thorium is a strategic option, not a silver bullet. The science is promising, but the engineering and economics are challenging. Staying prepared gives us more choices for the future. Is thorium cheaper? Not necessarily. The cost of raw fuel is a small part of nuclear power. Most expenses come from building and running the plant. Even free thorium wouldn't dramatically lower electricity costs. The real economic benefit could come from new reactor designs and simpler waste management. Thorium cycles produce less long-lived waste, potentially reducing future disposal costs. But specialized recycling facilities for thorium are expensive. There's a trade-off. Higher upfront costs for reprocessing, but possible long-term savings on waste. For now, uranium has the economic edge due to existing infrastructure. Thorium's viability depends on breakthroughs in technology and future market conditions. It's a long-term investment, not an immediate bargain. Thorium's real promise shines in advanced reactors. Fast-spectrum and molten salt reactors can use thorium efficiently, creating nearly endless fuel cycles. But commercial fast reactors have been slow to develop. Thorium could bridge the gap, offering better resource use and waste reduction in the meantime. Developing thorium now gives us flexibility for the future. If fast reactors remain costly or complex, thorium offers another path. Thorium and uranium cycles can work together. Thorium reactors can burn plutonium from uranium reactors. Imagine a future with a mix of reactor types, each playing a role in a resilient energy system. Thorium isn't a competitor, it's a complement. Building a flexible, integrated system makes our energy future more secure. Thorium helps us prepare for whatever challenges lie ahead. It's about options, resilience, and sustainability. So, what's the bottom line on thorium? It's not a magic bullet, but it's a powerful option for safer, cleaner, and more sustainable nuclear energy. Turning waste into fuel, extending resources, and designing safer reactors, these are real possibilities. The challenges are big, technical, economic, and institutional. But with steady research and investment, thorium could play a crucial role in our energy mix. The smartest approach? Develop thorium alongside uranium, using each where it fits best. In the short term, thorium can supplement existing fuels. In the long term, it could enable a fully sustainable nuclear cycle. Investing in thorium now gives future generations more choices. The quest for clean energy is ongoing, and thorium is an exciting part of that story. Science and innovation can shape a better world. Thanks for joining me on this journey into the future of nuclear power.
Before we end today's episode, For Science Salah Lotfy channel would like to extend its deepest gratitude to Professor Dr. Tarek Nagla, former expert at the Nuclear Power Plants Authority of Egypt, for kindly sharing and recommending today's important topic. We truly appreciate his contribution to this episode. To all our viewers, thank you for watching. We invite you to share your thoughts and questions about this episode in the comments section below. What stood out most to you in today's discussion? Let's keep the conversation going. With warm regards, I am Professor Dr. Salah Lotfy, Professor at the Egyptian Atomic Energy Authority. Here on For Science Salah Lotfy channel, I promise to continue bringing you the latest scientific research from all fields and from every corner of the world. Until our next exploration, stay informed, stay inspired. For Science Salah Lotfy channel, where science meets the world.